All right, so today's topic gonna be angle addition postulate and angle bisectors. Our goal, our essential question that we're trying to answer here is how do I find missing values of angles? So get things started here with a little bit of vocabulary. The main thing we got to know is what on earth an angle is. An angle is an object created by two rays that share a common endpoint. So picture time. We've got this ray. Let's call that ray AB. And then we got another ray that shares the same endpoint, A, going this way. So we'll say that ray is AC. Now, an angle can be named three different ways. We can put the angle symbol followed by the vertex. So in this case, in our picture, that would be angle A. Right, the vertex is A. So that'd be how we name it that way. We could also do the angle symbol followed by the 3 points with the vertex in the middle. So that would be angle BAC. Right, we got to put A in the middle because that's the vertex. Or we can do the angle symbol followed by a number that's found inside the angle. So maybe there's a 3 in there or something. And if there is a number in there, then we could just call it angle 3. So that'd be the 3 different ways we can name it. Also, for the second way, we could have flipped it and called it angle CAB. That would have been a valid way of naming it also. Okay, so we know how to name angles. We know what an angle is. Let's take a look at the angle addition postulate. Here's what that thing says. It says, given angle ABC and ray BD that's on the inside, on the interior of angle ABC, angle ABD plus the measure of angle DBC is equal to the measure of ABC. Now, first of all, that little M in front, if you see that, that is referring to the measure. It's talking about how many degrees it is, right? So this is kind of like how when we were talking about segments, if there's no segment symbol above it, it's talking about the measure of it. This is how we do measures with angles. So it's talking about how many degrees. So what on earth is this saying? The measure of angle ABD, here's ABD. That's our first part. Plus the measure of DBC, DBC, that's the second part, must be equal to the measure of ABC, ABC. So what we're saying here is that the two smaller angles combined, added together, if we add their degrees together, it's got to be equal to the whole thing. So let's just say that maybe this is 30 and this is 50. Then 30 plus 50 must be equal to 80. All right, that's what we're talking about here. Add those angles together. They got to be equal to the whole thing. Okay, so we can use the angle addition postulate. We can do part plus part equals whole to solve some equations here. Let's see what we got going on. It says BD lies on the interior of angle ABC. If ABC is 100, ABC is 100, that's this whole angle. So that'd be referring to all of this. ABD is 7x, that's this part. And DBC is 30, that's this part. Solve for x and the measure of angle ABD. Okay, so let's do a little part plus part equals whole here. So part plus part equals whole. The two smaller angles added together equal the big one. That's going to be how I get my algebraic equation that represents my geometric situation. And now that I got that, let's solve. Subtract the 30 from both sides. We get 7x is equal to 70. divide x must be 10. And then they want ABD as well, so let's take that, plug it into angle ABD. So the measure of angle ABD must be equal to 7x, that's 7 times 10. So that is 70. And that is 70 degrees. And does that check out? Does 70 plus 30 equal 100? Sure does. So give myself a check mark because I know I got that right. Always make sure you check your work. All right, so angle addition postulate. I know there's a lot of letters for naming the angles, but the setup itself and the solving is nothing crazy. Let's go to the inside here. Open that thing on up and check out the top left, where we got another example here. All right, so just a little bit more tougher algebra on this one. So it says EG lies on the interior of DEF. They are saying that DEF itself, the measure of DEF is 5x minus 55. That is this whole angle. So this whole thing is 5x minus 55. Then they're saying DEG, this part is 2 parentheses x minus 5. And GEF, this part over here is x plus 5. Okay, so let's do a little part plus part equals whole. 2 parentheses x minus 5 plus x plus 5 is equal to 5x minus 55. Okay, that is my part plus part equals whole. Let's go ahead and distribute 2x minus 10 plus x plus 5 is equal to 5x minus 55. And combine some like terms. 2x and x is 3x. Negative 10 plus 5 is negative 5. Okay. Let me subtract 3x. If I subtract 3x, I get negative 5 is equal to 2x minus 55. Add the 55 to the other side. Negative 5 plus 55 is 50. Is equal to 2x. Divide by 2, and I get 25 is x. Okay. Now, if x is 25, they want us to plug this back into everything. So let's plug it back in and see if this works out. I think the easiest one's going to be GEF, the blue angle there. If x is 25, then 25 plus 5, x plus 5 is 30. For DEG, a little mental math here, 25 minus 5 is 20. And 2 times 20 is 40. And then up top, for the big angle, 5 times 25 is 125. 125 minus 55 is 70. So, does 40 plus 30 equal 70? It does. So that checks out. So now we just got to write down our answers here. The measure of angle DEG, that was the green angle, is 40. The measure of angle GEF is 30. And the measure of angle DEF is 70. I'm just going to color code that. Oops, not that one. Thought I hit the green. So green angle was 40, blue angle was 30, yellow angle was 70. Okay, big problem. All right, so that was the angle addition postulate. Now let's check out the angle bisector theorem. So an angle bisector is a ray that divides an angle into two congruent angles. So if we divide an angle into two equal parts, we mark them with these little arcs. We can use the tick marks to mark segments that are congruent. Angles that are congruent get these little arcs. And so what we're saying is if that's a bisector, if it's splitting the angle into two equal pieces, then we can set the measure of this angle equal to the measure of this angle, because those two angles have to have the same amount of degrees if it got split in half. So the measure of angle ABD is equal to the measure of angle DBC. So let's try that out here. This says NP bisects MNO. It's splitting angle MNO into two equal parts. So they get the little arcs. It says that MNP, this side over here, is 5 times 4x minus 2, 5 parentheses 4x minus 2. And PNO, this side is 10x plus 10. Find the value of x and MNO. Well, if this thing got bisected, then our equation should be 5 times 4x minus 2 is equal to 10x plus 10. Oops, didn't mean to do that. So I got my algebraic equation to represent my geometric situation. I'm just doing part equals part since it got split in half. And now we'll solve. That'll be 20x minus 10 is equal to 10x plus 10. Subtract the 10x. Gets 10x minus 10 is equal to 10. Lots of 10s flying around here. We'll add the 10. We will get 10x equals 20. So x is 2. Okay, now x is 2, so now let's plug it back in to find MNO. Okay, so let me plug it back into the two different specific angles. If x is 2, then 4 times 2 is 8, minus 2 is 6, and 5 times 6 is 30. And then for the other side, 10 times 2 is 20, plus 10 is 30. So 30 and 30, I'm going to give myself a check mark because that's what we expected, right? It got bisected. And then MNO is the whole thing, right? MNO is the big angle. 30 and 30 make 60. So I'll say that the measure of angle MNO is 60. All right, we are cruising. So let's check out this guy up here. This one says BD bisects angle ABC. Okay, so once again, if it bisects it, these two parts have to be the same. DBC is 6x plus 10, and ABC, oh, this is interesting. ABC, this whole thing, is 12x plus 20. Find the value of x and ABD. Okay. So DBC, that's this part. But ABC is the big angle. That's this whole thing up here. Find the value of x and the measure of angle ABD. Well, we can't do part equals part because we don't know what the other part is, right? Normally, if it was a bisector, we would do blue equals yellow. But we don't even know what blue is. But here's the thing. If it got bisected, those two parts are the same, right? So wouldn't it be safe for me to call this angle also 6x plus 10 degrees? So with that in mind, you know what we can do? We could say that it's going to take 2 of those 6x plus 10s to be equal to a 12x plus 20. We could also write it out like an angle addition postulate problem by doing 6x plus 10 plus 6x plus 10 equals 12x plus 20. That's the same thing that I just wrote. I just like to distribute it. I like to write it out as I'm thinking that it's going to take 2 of the halves to equal the whole. That's the way that I prefer to do it. But if you want to write out 6x plus 10 plus 6x plus 10 equals 12x plus 20, you'll get the same thing. I'm just saying that it's going to take 2 of the yellows to equal a green. All right, so I got my equation to represent my geometric situation. Let's distribute. 12x plus 20 equals 12x plus 20. This is a little bit weird, isn't it? I got the same thing on both sides. So what happens here? If I subtract the 12x from both sides, I'm just going to get 20 equals 20, aren't I? Weird. Well, if I subtract the 20, I just get 0 equals 0. That's even weirder. So what does that mean? If all the x's cancel out and I'm just left with 0 equals 0, you might remember this from algebra. This means that there's actually infinite solutions. Kind of tricky, but that means that x could literally be anything. Now, it can't be something too big, like it can't be like a million. A million would mean that it would make sense algebraically, but it wouldn't make sense for the geometry involved. But if there's infinite many solutions, that means that we can't say what the measure of angle ABD actually is. Because like we said, it could be just about anything. So what I'm going to say, since we don't know what x is, since there's an infinite amount of x's that it could be, we're just going to say that the measure of angle ABD cannot be determined. Because we don't know what to plug back in. So, just a little tricky algebra thing to remember. If you ever get two expressions that are the exact same, and they cancel out to 0 equals 0, that means that there's infinite solutions. But that technique of doing 2 times the yellow equals the green, that is a good one to remember. All right, what do we have for our last one here? Ooh, this one's fun. Okay, so BD bisects ABC. That's the first thing that it says. So if BD bisects ABC, that means that these two parts got to be the same, right? Angle ABC is getting split in half. And let's label this thing. The measure of angle ABD is 5x plus 5. So this, oops, not the highlighter that I wanted. So this is 5x plus 5. This angle is. DBC is 3x plus 27. That's this one. And CBE is 2y plus 10. And ABE, that's this whole big angle here, is 140. That's this whole thing. Okay, we got a lot going on here. We want to find the value of x and y. Now, the first thing that jumped out to me is that bisector, because we know a bisector splits things into 2 equal parts, where we can do part equals part. And those 2 parts were 5x plus 5 and 3x plus 27. It was angle ABD and angle DBC. That was the result of us bisecting angle ABC. So let me start there. That's going to give me a way of solving for x. So if I subtract the 3x, I get 2x plus 5 is equal to 27. Subtract the 5, I get 2x is equal to 22. Divide by 2, and I get x is 11. Okay, so we solved for x. Now we gotta find y. And y is tricky because that's not a part of a bisector or anything. I can't set that equal to anything. But if I plug x back in, let's plug it back into ABD. ABD was 5x plus 5. That's the yellow angle. 5 times 11 is 55. Plus 5 is 60. So this angle is 60. And then for DBC, the green angle, 3 times 11 is 33. plus 27 is also 60. Okay, so now we can do a little angle addition postulate, because now I can do part plus part plus part equals whole. Now, if you didn't follow what I was doing there, I'm saying the yellow angle plus the green angle plus the blue angle equals the purple angle. Part plus part equals whole. Oh, I used yellow twice, I'm sorry. Yellow plus green plus blue equals purple. That's going to give me an equation that I can use to solve for y. So, what are we doing here? Let's combine some like terms. I've got a 60, and a 10. So that's going to be 2y plus 130 equals 140. Right? All those constants combined into the 130. Subtract the 130. Get 2y is equal to 10. Divide by y. Divide by y? What am I talking about? I'm so sorry. Divide by 2. If I lost my mind. Divide by 2, and I get that y is 5. Okay, now does that work? Let's just plug that back in. 2 times 5 is 10, plus 10 is 20. So does 60 plus 60 plus 20 equal 140? It does. So check. We did it. We solved for x and y. That was a tricky problem. Okay, we have reached the point where it is your turn to practice. So you got 6 problems on your turn little half sheet. Give those a shot. Pause this video. Come back when you're ready to check. All right, so name the angle 4 different ways. I could name this thing angle B. I could name it angle ABC. I could name it angle CBA. Or I could name it angle 1. Name angle 2 in 2 different ways. I could name that angle DBC. I could name it angle CBD. Remember, you can't name it angle B because there's multiple angle Bs. So we got to use the 3-letter method. Number 3, if ABC is 150, solve for x, you should do 2x plus 10 plus 60 equals 150. This is an angle addition postulate 1. 2x plus 70 equals 150. If you subtract the 70, you get 80, and dividing by 2 gives you 40. Okay, BD bisects angle ABC, solve for x. This should be a part equals part. 5x plus 10 equals 8x minus 8. Subtract the 5x, you get 3x minus 8 is equal to 10. That's 18 is equal to 3x, so x is 6. BD bisects ABC, solve for x and the measure of angle ABC. All right, let's do a little part equals part. 56 minus 2x equals 5, parentheses 3x plus 1. Distributing will give me 15x plus 5. Add the 2x over, I get 56 is equal to 17x plus 5. Subtract the 5, I get 51 is equal to 17x. That's going to give me 3 for x. And if x is 3, plugging it back in, 56 minus 2 times 3, that's 56 minus 6, that's 50. 3 times 3 is 9, plus 1 is 10, times 5 is 50. So 50 and 50 make 100. So I'll say the measure of angle ABC is 100. And then the last one, if ABC is 200 minus 2x, solve for x. Okay, so ABC is the whole thing. This is an angle addition one. 2x plus 30 plus 4x plus 10 is equal to 200 minus 2x. Combining like terms gives me 6x plus 40 is equal to 200 minus 2x. Adding the 2x over gives me 8x plus 40 is equal to 200. Subtracting the 40 gives me 8x is equal to 160, so x is 20. All right, hopefully you guys did well, and that is it.